Hi. A few years ago, I bought myself this science education kit. It was in my room for 2 years or maybe 4 years. I didn't do anything with it. I just remember I assembled this fan, propeller, standard solar panel. You can see on the dust that it's a few years since I touched it, but we will open it. Well, let's open it, see what's still inside. Things I have used, but documentation, DVD or CD, whatever, stickers, something, all kind of stuff. The most important thing is this one. It's something you need to create hydrogen. It's saved, and I don't know if it will work after those years. There's a potentiometer from 0 to 100 ohms. Very nice. There is these are the batteries. You can the batteries put in here. They are still in here. I feel it. I don't know if they work. Some other things. And here's the fuel cell, or the cell that converts hydrogen, how do you call it in English? Waterstof, hydrogen, into electricity. We will find out. Then finally, unpacking it all, this is what we get. Some extra rings, I don't know what they mean. Some glass. This is what is this? This is a motor. Or maybe you can use it as a fan, but the main object is this one, that is the windmill. That should start it. Put the fan on. Look if it's turning. And there's the energy that is generated is going here and it's coming out here. It works. The fan was hitting the pole, so I threw it a little bit out. Now it's running fine. I unfolded all documentation that is found. I do not remember where I bought this. I think it was from some reunion or wind energy people. First things I see here is this fan. It's not running very smoothly. Maybe I should lubricate it with some oil. Anyway, I like to have a beer with it. Some like a glass of wine, I like a glass of beer. And the documentation is in English. There are two wind energy assembly guy. So it's a little bit confusing if there are two assembly guys. This is some, I bought it from Conrad, I see, in the Netherlands. And there are some other projects you can buy. Well, these are assembly guides in different languages, in German, English, whatever. And I see here, this is a small fan. And this one should be connected to it to make it turn. Well, the energy is delivered by the big fan. Well, here it says that you can connect the fan or to a LED module. Here it says that you can connect the windmill that produces energy to a LED module, whatever I found. So this is what I found. I think this is the LED module. Imagine. Connected it to the windmill. I didn't try it before, but I will start the energy. Well, it will look. Are we going to see something? Or is the energy too low? Well, nothing happens here. I do not see. Red is plus, black wire is the minus. Maybe I can make it a little bit higher. Okay, oh, there it is. There's some electronic circuitry that makes the let's go blink. So if I turn the fan a little lower, there's no energy. So I'm hardly on the edge of. Maybe I can put it a little bit closer to give it a little bit more energy. It's still, if I put it back to previous state, it doesn't. So it's very insensitive. Well, this works. Well, I'm just fumbling around the manual to try to get some overview of it. I see here experiment 10, so we have to go back. Renewable energy support, over here. Wissenschaft Lernset für erneuerbare Energie. Das is Deutsch, that's Dutch, that's English, that's German language. So we should be here. 10, 7, experiment 5. We will start all the experiments just one by one. And then we have experiment 4, it's inside this lime. There's not experiment. There's experiment 3. So we have to go to the front side. I see here experiment 1. Here's experiment 2. So we just start one by one executing all those experiments. Experiment 1 is to make the solar panel, this one, to make the LED module, make the LED blinks. I now have connected it to the windmill, but I have to connect it to this solar power. Well, today it's not a sunny day, so I do not have energy from a solar power, but maybe I can try. So I want to try to get enough solar energy. Therefore, I have to go. Don't look at my messy room. Just give you an impression of where I'm working in. Don't blame on me that I'm so, well, it's a lot of mesh. Look, here's my ladder I use sometimes, and I connected other projects to it. But now I connected the solar panel to my ladder, and then I will connect this to my other system. I already do have some connection from here to my workbench. Going up down there. So I need to connect this to this. So I finally connected this solar panel to this antenna, because it doesn't mind. What got my attention is that this pin, this red pin, is very corroded. I don't know why. Looks at this as if it has been moistened or whatever. But anyway, the energy, if coming out of the solar panel, will go to my workbench. Finally, this is where my antenna cable enters here, so I have to make some interface to here. Well, I connected the wires of a multimeter, but it shows nothing. Something there must be wrong connected. Well, I will first do a basic test. This is my battery holder. It's filled with batteries, I can feel it on the weight. Connected with the crocodile clamps from China to my multimeter. And okay, I will have to switch this on to the right and see 2.6, 2.5 volt. It's a little bit unstable, which I do not understand. Maybe it's bad. Oh, this must be bad connections. Due to bad connection. 1.8. Something strange I discovered. This red pin also is going from the battery is also very corroded. It's green-like colors. It's the same. We go to my solar panel. We have this plus. Also has the same green copper-like corrosion. I do not know what it means, but we will find out. I twisted this thing many times. Now it's stable at 3.1 volt. Now I'm going to connect this voltage to my solar panel to see if the connections from the solar panel to my workbench is okay. I connected my battery. I should put it on. So, to my antenna cable, and I use these grippers or whatever you call it. I use a lot of them, different kinds, and I always connect them together by some reusable tie wrap. You can open it and close it. It's a very handy tool. Connected my multimeter to the antenna, but I still read irregular values. So there must be something wrong. I think some of the corrosion. I must confess, it's not only the positive, but also the negative wire of the solar panel had corrosion on it. Only less than the plus. I rubbed the connection on the plus side of the solar panel, and finally that's the problem, is that corrosion on the connectors has caused a problem. So now I see 3.1 volt is generated by the voltage pack on the antenna side, on the solar system side. So now I will reconnect the solar panel to this cable. I still want to know, why is the plus, the positive side, so corroded? It's green all over, and the negative side, it's completely clean. This is from the solar panel wires. So there must be, or it is some bad production process, or there is something interacting with this environment. I do not believe in ghost stories or woke, but there must be a reason why this red one has corroded so much. So finally I reconnected the solar panel with its crocodile clamps to my antenna, and I rubbed the red wire many times to be sure it makes a good connection. So now we will try to find out what voltage this solar panel delivers on this cloudy day. Well, it says 0 voltage. That can be true. Even in a cloudy day, there should be any voltage. This fucking corroded connector is the cause of many problems. I'm not a scientist, but I know with vinegar or whatever, you can clean up this one. I don't know how to, but I do not want to use this cable anymore. You cannot trust it. I rubbed it many times to get it stable, and it produces the voltage of 1.55 volt at this cloudy day outside. I wonder why I make myself so difficult, because there are enough wires which are very clean. So I will use this one. So I finally replaced the red wire with a good one, with a clean one. I connected it to my multimeter and I see 1.55 volt that is generated by the solar panel on this cloudy day. Some notification. These breadboards are very nice to experiment with, but if you have any trouble, the contacts resistance between these breadboard connections, maybe some 1 or 2 ohms. So it's not very reliable, but for most experiments this will work fine. So first of all, I want to create a stable connection between this breadboard connections, or between these 2 points, to my workbench. Sometimes I think, why should I do this much effort if I just can use 2 simple wires to do it? My experience is, once you create a very good interface, you will always reuse it anytime. So time to investigate how to make a good connection, it will pay out in the future. And a second thought, a principle of mine is, never change an existing connector. For instance, I have this one that can be connected to my volt or power supply, and on the other side I put some, you name it, I don't name it. You can use it with this Wago clamps, very useful. But you think, oh, I just cut off and make another connection. Never do that. If an existing cable works, don't change it. Just make another cable that will do the job. For instance, I use this, you can use any Ethernet cable with those wires in it. They are of a very good quality. So I want to make a connection from the breadboard or from the cable to my workbench. And I use a few meters of this, I think. I just cut it here, and then I try to get the wires out of the mantle. One of the way doing this is just fasten it into your workbench. I think it's a very handy tool, and you just keep rubbing it. It's about 1.5 meter. It gets hot, and slowly keep doing this. The cable will come out. And with warm, overheating hands, finally this is the product. Automantle you can use for anything else, I don't know, a water system or whatever. And the inner wires, 4 sets of twisted pairs. Unfortunately there's no black and red, so we have to choose our own colors for the plus and the minus. But maybe this is not a good solution, because these wires are hard cord, or you call it. There's only single copper wire and not multi, so they will break off very easily if you bend them too much. I must be honest, I do not have the inspiration to create me another cable, so I will continue using this, and I will connect it to a pin header, which I have a lot of them. And the pin header, I then, whatever it is, take any pin header, I can put it in here. Okay, it doesn't fit very well, but it's okay. Soldering it, because if you put it in a breadboard, the metal will conduct the heating. If you put it in here, it's easier to solder it. But I found out these are not single copper wires, they have a multi-wire, so they are very suitable. And I wire them to 2 connections, so on the breadboard you get a stable connection. Not when you use one, it can go around, and this one just is fixed. But anyway, when doing these kind of things, I like to listen to, you knew it, airplay or radio play.
Again, taken our place in the formation.
This is the
Mitch and I were needed to handle freighter number 6, so Jet and Lemmy had their work cut out running the Discovery between them. However, in between watch and inspection,
this is very nice, but I normally listen to the Dutch version, which is this one. It's our own Dutch translation of the. I like to hear this play on the background when I'm experimenting with electronics. Anyway, how do we connect the other end? I think we should use some eindhulsen. You know, I don't know the English word, but there are these things. You connect them. You use this kind of apparatus to finalize a wire. Finalized it with this shrimp. First I shrimp it, but I shrimp it 3 times on a different distance. I do not like this kind of, but anyway, I had bought it, so I use it. But I use it 3 times, 1, 2, 3, so I make a very good contact to the wire. Still another update on the background noises I use. I did not really know what it is called in English, but in Dutch it's called a hoorspel, and in English it's a radio play. So I like to listen to the radio. I will put out my lamp. Radio play about science fiction, and it's about a journey to Mars. I will.
Ship Discovery here, hearing you loud and clear. Hello, number 6, hearing you. Come in, please.
Hello, Discovery. Number 6 calling.
Is that you, Mitch?
Who else? What?
Well, I think maybe modern people think it's old-fashioned, but in former days we had no internet, nothing. We had only once a week we listened to a radio, listening to this radio play. It was very exciting. Modern people cannot understand this. But anyway, so now I will make a solid connector construction by gluing those two connectors together with the super glue. Then I outline them by putting them in here. But somehow that doesn't work, but maybe they are spaced too far away from each other, so I will put me another drop of glue. Just be careful, don't touch it and your fingers will never get apart again. I think maybe using cola or something you can separate your fingers. Because those connectors do not connect to each other, there's some space between it, so I place got me some spacing. I think in theory these papers are 0.1 millimeter in size. So you just put them 4 pieces of it, 0.4, to get them really connected together. Well, it doesn't seem a good solution. It doesn't fit together. So I wonder if I put some two other in the opposite direction, so in this orientation, and I solder it to this orientation. Well, trying out different systems, I thought by myself, why shouldn't I use this glue pistol? I glue it on it, and I put a paper on the ground so it doesn't fixate to my PCB, and we will try it out. After cutting the surrounding paper, this is my new connector, the solid one. So then I finally used these Wago clamps. I ordered them by a box. I think they are, I don't know, between 30 to 60 cents per piece. I just ordered a lot of them. I never get loose of them. I glue them together with this one. I use my tissue to remove the excess of the glue, because your fingers are many times together, wired together. And then I put them on this side, push on here to outline them, and then push on here to outline them, and then I let them dry. Maybe I use some clamps or whatever type, and then they will connect together forever. So finally I got myself a solid interface to my solar panel, it looks a little bit strange. It's like an old, how you to call it, fossil. But anyway, it is connected with 2 pins to the one side and 2 pins from the other side, so it's very solid connection. And from here we will work on it. But I think this video is getting too long. We will have a second video to explain the rest of the part. Thanks for watching.